Right, so let's have a look at how we simplify expressions that have indices in them. If we have an example such as 2 to the power of 2, 2 squared, multiplied by 2 to the power of 4. If you were asked to evaluate that expression, then we'd have to think, right, let's first of all expand these two terms. So what is 2 squared? Well, we've looked at this already, and it's 2 times by itself, 2 squared. And what is 2 to the power of 4? Well, we know that that one is 2 times by 2 times by 2 times by 2. 2 to the power of 4. Okay, hang about. So if we put these together, what we've actually got is 2 times 2 times 2 times 2 times 2 times 2. And if we were to pull that into a single number, well, that equals 2 to the power of 6. And that's how we would evaluate that expression. Interestingly, you'll notice here that if we look at the indices, these little power numbers that we started with, 2 to the 2, 2 to the 4, effectively we've added those indices to give us our final power, our final index, 2 to the power of 6. Let's have a look at that in algebra, a more general case. If we'd have said we had, let's say we're dealing with x now, a variable of x. We don't know what it is, but it's x cubed we're interested in, and we're going to multiply x cubed by x to another power, let's say x to the power of 4. Well, we're going to do just like we did over here. We're going to expand each of those terms. So let's first of all deal with our x cubed. Well, that is x times by x times by x. And we're going to multiply that by x to the power of 4. Well, okay, so that's multiplied by x times x times by x times by x. So if we look at that in one number again, just like we did in our first example, x times by 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 x equals x to the power of 7. And once again, notice that all we've actually done, and a quick way to this, is to think, because our base number is the same, it's x, well, we can just add those powers. 3 plus 4 gives us 7, x to the power of 7. If we use that in a more general case still, so we've used some algebra in our base number here, but let's generalize these indices as well, these numbers, these power numbers. What's that going to give us? If we said this time we're going to have x to the power of n, and we're going to multiply that by x to the power of m. Now, if I use what we've already shown, demonstrated here, actually, I'm going to miss this middle step here. I'm going to jump straight to this one. What did we do? We added these two powers. So x to the power of n times by x to the power of m gives us x to the power of n plus m. Adding the powers. And that's how you would use that algebraic approach in a numerical example, if you got one in your exam like that. Or you might actually get one that involved algebra. Finally, I wanted to have a look at an example where we have a number in front of the x. So in none of our examples here did we have anything before that x. These are called unitary coefficients. Coefficient is the number before x. So if that is not 1, let's have a look at an example of, say, 2x squared. And we wanted to multiply that by 3x to the power of 4. Okay, so that's starting to look a bit more complicated now. And how are we going to deal with that? How are we going to evaluate that? Well, we're going to use what we've just demonstrated, but before we do that, we need to think about what does 2x squared mean? And in order to work out exactly what that means, we're going to have to use BIDMAS or BODMAS, which talks about the order that we're going to tackle these operations in. So we've got 2 and an x, of course, that means 2 times. There's a sort of hidden multiplication sign here. And our x is to the power of 2. But what do we do first? When we've got a power or an index and a multiplication, from BIDMAS, we do the x squared first. So that means 2 lots of x squared. 2 times x squared. Okay, 2 times by x squared. Similar thing over here, we're multiplying this by 3 lots, 3 times x to the power of 4. So we've expanded that slightly. Why have we done it? Well, actually, it helps us because we can reorder this now. With multiplication sums, we can reorder them so that we have our numbers on one side. We deal with our numbers first, and then we'll deal with our x's afterwards. So let's just rearrange this slightly and look for our numbers. We've got 2 times by 3. No more numbers. We're now into x terms, variables. We've got an x squared. And we've got an x to the power of 4. Okay, a number of steps involved here, but we're getting quite close to our answer now, and we can start to look at tidying this up, because 2 times 3, well, that's nice and easy, isn't it? That's 6. Times by x to the power of 2 times by x to the power of 4. Well, if we go up here, x to the power of something times by x to the power of something else is x to the power of those 2 indices added. So let's put that into practice down here. We've got 6 times by x to the power of 2 plus 4. Or 6 times by x to the power of 6. We don't need that times. 6 times 6x to the 6. And that's how we handle multiplying numbers and algebra with indices.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.